discuss about IPv4 and IPv4 classes. And that too, we discussed about a class A, class B, class C, class D, class E. And I already told the classes we use here only 3 classes. Why? Because of unicast. We can assign to any device either manually or through DHCP. We use these 3 classes only. And as I said, IP address is look like this. Okay. So this is, we call it as an IP address, right? It can be like, so these are so many different type of IP address. Class C IP address, class B IP address, class C IP addresses are there. So this IP address again is split into 2 parts. This IP address is again 2 portions are there. One is network portion, another one is host portion. One is network portion, another one is host portion. So what is the network portion? What is host portion? Simple. You are in a floor, for example, mm, same floor. Meaning is, for example, you take 101, 102, 103, 104, 110, okay, 111, or maybe 121. Cities, for example, the first one represent floor. The remaining digits represent door number. So door number is individual, first door number, second door number, third door number, fourth door number, fifth door number, like this. This is the door numbers. This represent floor. For example, I have a like this. Like this. So what is this meaning? Second floor. This is belongs to second floor. This is belongs to first floor. So how can we divide first floor and second floor is based on the floor number, right? The same way in the network, in the IP address, we divide a network into host portion, means IP address into host portion and network portion. Host portion represent host number. Network portion represent what network it is. This is good to remove. Now, why we should we have a Cisco packet tracer? I'll try to show from there. Okay. Already, oh, keep me sign in for 3 months. Okay. So here it is. First of all, a small normal laptop I am taking, and I need some computers. Okay. Then we need to connect. So this is a simple network. These are the devices are connected. Okay. Now the switch port is turning on. So once it is completely on, so I'm going to assign an IP address. Okay. Yeah, that's it. That's three is enough. If you see whether they are able to communicate or not, you can check from here to here. Sir, packet is communicating successful. From here to here, it is communicating because physically they are connected and logically they are in the same network, the 10 series network only. This is the network portion. Okay. So devices it connected and we assign an IP address so they can able to communicate each other. Okay. So what I'm trying to say is, yeah, here it is some roll numbers. Also I given an example, but before that one. So network portion and host portion. Host number and network portion is there. So I will show you with an example also once again. I will try. Okay. This network portion and host portion is divided like this. Check it. If you take class A IP address, the very first portion is network portion. Remaining is host portions. Okay. If you take class B, the first two portions are network portion, remaining is host portions. First three portions are network portion, the last portion is host portion. Okay. So first portion is network portion in class A. In class B, first two portions are network portions, and class C, first three portions are network portions. Okay. So it meaning is these three represent host portion means host numbers only. Here is a rule. Okay. Here is a some rules you should talk first. Means if you are to communicate between the devices, so you want to communicate. What is the requirement? So to communicate, what we need? Connectivity, IP address, protocols, right? So here it is in the IP address pattern. So network portion must be same for the devices. Okay, their network portion must be same to communicate. Okay, so same LAN network, same segment. In the same segment, entire devices must have a same network portion. The host portion is different, at least in a octet. A host octet. It means I take 10.0.0.0. Okay. So otherwise take 11. So network portion is 10. Host portion is 0.0.0.7. Okay. So another system IP address is like this. Network portion is 10, host portion is like this. In case I have another computer with a 10.0.2.23, 0.2.23 host portion. Either in one part of host or two parts of host or all parts of host can be different. No problem in it. But must not be same always. Okay. This is also good. But must not be same. Must not be same means you cannot assign like this 0.0. So you cannot assign. So this is and this are having a conflict. These two are having a conflict. Conflict means same IP address assigned to multiple layers. If it is like this, no problem. If it is like this, no problem. Okay. This is not same. Host is with a different number. Maybe this is same, but this is not same, right? So this is different from here. No problem. Next. See, it is different network. See, this network is changed. Okay. We cannot communicate through different networks directly. In the same segment, we cannot communicate with a different network versions. When network version different, it is different network only. Okay. These are all same network. This is different network. So this is to our same network and this is different network. This is separate network. This is separate network. Understand network portion and host portion. It goes for same for class B and class C and class C also. I'll show you that one. So guys, here it is. Views, it is 11, 10.11, 10.12, and this is 10.13. And here also I'm trying to show you this is 10.0.0. No, no, no. 1.23. No problem. Same 10. I didn't changing the 10. I keep 10, 10, 10 only. Starting one is 10. So same network version. Okay. So same 10. Okay. So these are all 10. This is also 10. In this one, we follow the sequence. 10.0.0.11, 10.0.0.12. Like this. In this one, it's 1.23. One second. So if you look at whether from here to here, it will communicate. All are tens only. Check it. From here to here, yes, successful. Okay. So from here to here, can it communicate? Successful. It means these are all logically same network only. Logically and as well as physically same network only. So for this species, we'll try 11 series. 11. This is also class A. Okay. 11 is also class C. First octet is 11. So we'll try from here to here. Both are 11 network. So communication. From here to here, in progress. Failed. Why failed? Or from here to here, failed. Why failed? Why they are unable to communicate from here to here? Tell me, anyone? Why from here to here can able to communicate? Why it is not able to communicate from here to here? Physically connected, but it is failed to communicate. Why? Tell me, anyone. Try to guess something. Come on fast, guys. Not getting that. Right. Yes. Okay, now tell me, guys, why can't we communicate from here to here? Why can we how can we communicate from here to here? Both are connected, the same search, but they can't able to communicate. Okay. So why? the logically separate networks. They are logically separate networks. So physically, all these devices are connected each other, but logically separated. Why? Because of their network portion is different from here to here. This network portion is same, this network portion is same, but from here to here, different network portions. Okay. So if devices want to communicate in the network, either network portion must be same and their network portion must be same and host portion can be different. Okay. Not not exactly. It can be one portion or all portions of host can be different. See, here it is only one portion of host is different. Here two portions is different. Here it is all three portions are different. Okay. So it can be one portion of host or all portions of host can be different. No problem. But network must be. Devices are in same network and communicate each other means their network portion is same. So devices are in the same network means the network ID is same. If you say all these devices are in the same network, these devices are in the same network means their network portion is same. So it is PC1 and PC2. It is class A. First portion is network portion. These two portions are same. So PC1 and PC2 can communicate each other. If you see the PC3, it is different from this. So, but not PC3. It is different network. If you see here, it is multiple 5 PCs are there. I have a 5 PCs. 5 PCs I configured IP address like this. So first one PC1, PC2, PC3. It is class B. First portion, next portion, both are. I have to check it. So both must be same. So it is 181, 181, 181, 23, 23, 23. It means all these three are in a same network. Host can be different. Either one portion or multiple portions can be different. Here it is. First octet is same, but second octet is 24. This is 23, this is 24. This is 182, this is 23. See, one of the octet is different, or both can be different, or at least one of the network portion is different. It is different network. We cannot communicate directly. So PC1, PC2, PC3 can communicate each other, but they cannot communicate it to 4 and 5. This is class C. Class C is a three are a network portions. First portion, second portion, third portion. All these three are a network portions only. So you have to check it, class C. And these three portions must be same. Host portion is only one, so obviously that portion only is a different one. The host portion, you can see first portion, second and third. Third portion is different. And here it is second portion is different. Here it is first portion itself. So PC1 and PC2 can communicate each other, and other systems we cannot able to communicate different networks. This is different network, this is different, this is different. So how system divide portion, how to fix network ID, and something I have written here. I will take a simple example like this. Guys, I have three systems. For the three systems, I assign IP address. I take PC1, this IP address, PC2, this IP, PC3, this IP address. Okay. Now I connected like this and I try to test it. So I'm trying to test it like a PC1 to PC2 communication is there. PC3 is not able to communicate. And understand guys, PC1 and PC2 or communicate each other. Why? Both are in same network. Okay. So you find what happened. PC1 is able to communicate it to PC2. But PC1, PC2 can communicate each other, not to PC3. What is the reason? This is you entered wrong IP address. These are the same IP, same network, communicate each other. This is wrong IP, so wrong network. You done a mistake. What to do? Anvita, tell me. This is differ from other. What to do? You done a mistake by entering IP address. What to do? So simple. I have taken a switch. There is a computers. One, two, three. Guys, yeah, you must talk. Someone at least talk. Otherwise, I think I am disconnected. It's not about you understand or not. Where is our IP address? PC1. Got a message. Yeah, started query. Okay, so I send an IP address. I'm testing communication. It's a packet from here to here. Successful. From here to here. Failed. From here to here. Failed. Why failed? I think you understand why it is failed. Why it is failed?
Network portion is different.
Network portion is different. Very good. Okay. Now, what I have to do? First, check the IP address in the systems. Okay. I check the IP address. This is showing 111. This is showing 110. Very good. So both are different networks. I understand now. The first portion class A, first portion must be same for a same network. It is different. I entered wrongly. I realized I by mistake instead of 110 I put a 111. What to do? This is by mistake I have done. What to do? Simple logic, guys. There is no right and wrong answer. Simple logic. All troubleshooting with a simple thing only it will work. I need a simple name. Hmm. Anvita is there, so we'll see. Yeah, okay. Hrithik is there. H-R-I-T-H-I-K, right? So I think I have done mistake. What to do?
Change the mistake parts.
Yes. Change the mistake part. Very good. So where I have done the mistake, change it. So now it is, I change my 111 to 110. We'll try once again. That is the correct answer. See, now I can able to get a success. Again, we'll try once again. From here to here, yes, successful. From here to here, yes, it is successful. So what we have done by mistake? If you got a chance, we'll try to change, correct the mistake. So if two systems are not communicating, one is connection issue, second one is IP address. In the IP address, network portion is same or not. Okay, it is different. If both are in the same segment, same network, same segment, but different network portions. So you have to put a question, why different net version? You're entered manually. If you done mistakenly, then what you do? You change it. This is according to the plan. This is the network portion, but this is wrongly entered. You have to change it. That's a good, very good, guys. That's the answer. I want waiting. Okay, very good. The last part of this one is only subnet mask. I will tell. Okay. So thing is, your system, we understand by seeing that the first portion of IP address is a which class of IP address, and based on that we can understand by default which is the network portion. Okay. Now here how system will understand based on the subnet mask. Okay. Using this subnet mask, system divides your IP address into network portion. Okay. Your system divide your IP address into network portion and host portions. Subnet mask is divides your IP address into network and host portions. And subnet mask tells what is the network ID of your IP address. Subnet mask gives what is the network portion of IP address. So, is this species can able to communicate each other or not? It depends upon network subnet mask. Using this subnet mask, it calculates network ID, and all systems network ID is same, they will communicate. Means both system network ID is same, they will communicate each other. Just for here writing purpose only. See guys, when these two systems want to communicate each other, they're having their IP address and subnet mask. This subnet mask is divide this IP address into network ID and host ID. Okay, network ID and host ID. So from network ID we are getting, so network portion and host portion network ID we are getting here. And this network ID and this network ID is same, so both can able to communicate each other. Okay, same thing. So this is having a network ID. Okay, network ID, network ID, network ID, network ID, network ID. All these devices, network ID is same, so they can communicate each other. So when this system is trying to communicate here, so they check what is the network ID, what is the network ID. Both are same, they'll communicate each other. If this system want to communicate this system, so network ID, and network ID. Both are same, they will communicate each other. Not same, they won't communicate each other. So how systems can understand their network portion and host portion and how it is get their network ID based on their subnet mask. So when you are assigning IP address to a system or a device, you given a IP address and subnet mask. The by default, the subnet mask, because of the subnet mask can be changeable. If you change the subnet mask, the network and host portions also changes. But by default, we take a default subnet mask here. SN and IP address depends upon default subnet mask changes. For example, here I'm trying to change my subnet mask. Again, I'm typing here 182.17.8.10. So it is class B. So automatically some subnet mask is came. For example, I put a 192.16.7.19. See, subnet mask is different. Okay. For example, I put a 12.0.2032 like this. Sorry. Yeah, 12.3.4.5. Anything. So 12 is a class A. So automatically system can recognize and system is provide the required subnet mask. Okay. So what I'm trying to say is default subnet mask where the network portion is there, there it is 255 will be there. Okay. So first portion is network portion in class A. The first portion is 255.0.0. So here it is ones represent network, zeros represent host. Just for now, just remember only these things, guys. Class A 0 to 127. The first portion is network portion, remaining are host portions. If you write in the subnet mask wise 255.0.0.0 for class B 255.255.0.0, class C 255.255.255.0. So for class C, first three portions are network portions. Here it is, you can see all 255s here. Class B, first two portions are network portions. Next two portions are host portions. Okay. So we are generally recognized based on this, but for a system, we assign subnet mask. For system, we assign a subnet mask. Even in my system, I have an IC, right? NCPA.CPL. Click at here, IP address, subnet mask, class B, class B. For this one, you'll see class C IP address, class C default subnet mask. This is manually configured, right? So I can able to change it. So this is manual IP for this adapter. So manually I configured it. For example, here I give an IP address. Um, so like a 200.0.2.3. 200 is a class C. So it is class C subnet mask. Automatic. 10.0.0.11. Class C. Okay. So you will give IP address, subnet mask compulsory. Okay. So by the subnet mask divide your IP address into network portion and host portions. It will divide your network portion and host portion. And it also gives your network ID. To communicate in the network, their network ID must be same. So how system will understand same network ID using subnet mask? Guys, default subnet mask for class A is 255.0.0.0. Class B is 255.255.0.0. Class C 255.255.255.0. How system will calculate use AND gate operations? What is the advantage of this one? I will finish up to here. So this part I will explain later. I'm feeling very bored. Okay. So guys, now we are using lot of IP addresses as our requirement, right? But in publicly, there's a very limited number of IP addresses. Here I have a network. In my office, I have a 50 computers are there. Now my boss told me assign a IP address to all the 50 computers. Which class of I have to take? From class A, class B, class C. Which type, which class I have to take it? You'll see here. How many host portions in a class C? Only one host portion. One host portion means one octet. One octet means 8 bits. 2 to the power of 8 minus 2 is a 254 host in single network you are getting. So it is, I'm taking class C here. So 192.168. So for example, 1.0. This is my network starting address. 192.168.1.1, 192.168.1.2, and it keep goes, right? 192.168.1.254, okay? 192.168.1.255. This is the last one. This is last. This is starts. But originally we don't use that one. So how many numbers? Totally 256 IP address. If I write like this, if I write like this as a next one, this is other network. Okay. So look at here. This is one network. This is different network because network portion is different. Network portion is different. Class C. First three are network portions. Remaining is host portion. First three are network portion. This is host portion. And this is different from here. Compulsory it is different network. The first one we call it as a network ID that represent what network it is belongs to. The last one we call it as a broadcast ID. Broadcast ID. Network ID, broadcast ID. Both we don't assign to any system. So this is called a first valid IP address. First valid IP address. This is last valid IP address. First valid IP address. Last valid IP address. Means you have a computers. Okay, you can start assigning 192.168.1.1, 1.2, 1.3, 1.4, 1.5 like that. You can assign to the each and every device. Up to 1.254 you can assign. 1.255 you cannot assign. 1.0 you cannot assign. So that's why it is -2. First IP address represent network ID. The very last one in the same network is broadcast ID. So remaining things we can assign to any device. And when network changes, once it is there, it is different network. This is another network ID. This is another network, their network ID. See, this is another network. Okay. So here there is an example I try to say. I have 50 computers. From class C, I'm getting totally number of hosts. 254 means 254 computers in the same network, same logical network. I can connect, I can make a communication up to 254 hosts. And a class B is the first two portions are network, remaining is host portions. Two host portions means two octets, 8 plus 8, 16. Okay, so 65,534 host in the same logical network you can connect and we can make them connect in a single network. The single network. So how it is? For example, class B 172.16.0.0. This is network ID in a this particular network. So class B means first two portions should not be changed. This is the first valid host. Okay, first valid host. It keep goes on. 172.16 0.254 172.16 0.255 172.16 1.0 172.16 1.1. Okay, so if you look at like this, guys, what is the most important here in the same network means class B. These two portions must be seen. 172.16 255, 254, 172, 16, 255, 255. So this is broadcast. Okay. This is the network ID. This is broadcast ID. From here to here, same network only. If you want to write second, next one, automatically it is 17.0.0. This another network ID. You can look at here, network is different. So this is entirely one single network only. You know how many hosts? You take a PC, first one, second one, third one, fourth one, fifth one. You keep on assigning up to here, you can able to assign. Okay. So number of hosts are 65,534 computers. You can able to give an IP address in a single logical network. Same goes for class A. Only one network portion, remaining are host portions. 2 to the power of 24. This is almost like a 16 million host you can able to connect in a single network. So what is the advantage of it? Why we should divide a IP address into multiple classes? For different purposes, for multicasting purpose, some are reservation purpose, future purpose. Another one is limiting number of hosts per network, limiting number of hosts per network, so we can best utilize IP addresses. I have a 50 computers. I choose class C because class C will give you up to 254. Now my boss increased another 50. Now it is 100. No problem, still I can use class C. And plus 100. Now it is 200 computers. No problem, class C. I have another computers now added. Now it is there is a problem because this is 300 computers. It is not 300. So you have to move to the class B. Okay, because it is crossing this 254. So I have to use class B for make all the things into one single network. Another 200 computers are added, means 500 computers. Class B is suitable. Why? 65,534 devices you can connect it. 5,000 devices, 10,000 devices. No problem. Class B is useful. 60,000 devices. No problem. Class B support is there. It crosses 65,534, then you have to plan for Class C. See, depends upon number of devices in your network, you choose which class of network is suitable for your organization. Okay, guys, understand up to here? What is IP address versions, classes, how to identify IP address, what is the network portion and host portions, and what is the default subnet mask, a number of hosts per class of network, per number of hosts per network in a particular class, and network ID, host ID. Anyone please respond? Guys, if you don't speak, I can't take the class. Okay. Something you have to respond, right? Understand, not understand, you want repetition. At least you read it. Because you most of your batches, same thing happens. Like people don't talk. I keep talking. So definitely I don't mind about whether people are talking or not. So I become habituated to teach like this. Originally, my all classes are interactive mode. Okay. No problem, guys. It is not, it does not matter. So compulsory today.